So in day 7, we're going to review graphing from factored form, which this is in standard form, and we're also going to look more in depth at the zeros of quadratics. So for the warm-up, given the following quadratic equation, complete the following steps. So first step, we want to put this in factored form to find the x-intercepts. And you can do it several ways, box and circle, you can factor by grouping. I'm going to use, I like the box and circle, so that's what I'm going to use. Before we do that, though, we can factor out a greatest common factor of this right here. If you notice, we can divide each of these terms by 3. So I'm going to do that. Let's erase that. All right, so we have 3, and I'll divide each term by 3. So we have x squared plus 10x plus, and 72 divided by 3 is, I believe, 24. All right, next up, I'm going to put the trinomial in a box and circle. So this guy right here in a box and circle. So we got x squared, we got 10x, and we got 24. I want to know what multiplies. Let's change colors here. What multiplies, let's use blue, to the first box and the last box. So 24x squared, that adds to 10x, the middle box. And that would be 6 and 4. So 6x and 4x multiply to that. Let's get the outside of the box. We know that x times x is x squared, x times 6 is 6x, and x times 4 is 4x. So here's factored form. Don't forget about that 3 we factored out, and we have x plus 4, x plus 6 in either order. The x-intercepts, we want to know what makes that equal 0. So we look at the first factor. What makes x plus 4 equal 0? We can make an equation and solve, but we know that's negative 4 makes that 0. And what makes x plus 6 equal 0? That's negative 6. So those are x-intercepts. The y-intercept is when x is 0, so think about plugging in a 0 for every x. So we get 0 plus 4 and 0 plus 6. So that's 3 times 4 times 6. All right, 3 times 4 times 6 is 72. All right, so our y-intercept is 0, 72. That's a pretty big y-intercept there. All right, the equation for the axis of symmetry, that is the point in between our x-intercepts. So we're looking at negative 4. We're going to add the 6 to that, but then take half because we want the middle. So that's 2 over 2, which is 1. Okay, so x equals 1 is our line of symmetry. To find the vertex, we plug in that 1, the line of symmetry point, and we solve. So 1 plus 4, 1 plus 6. All right, so we got 3. Oh, I'm sorry. I plugged in the wrong point, so let's go back. Okay, so here's where I made my mistake. To find the line of symmetry, we have to add negative 4 plus negative 6. That's why my numbers weren't working. So again, we add our zeros together, negative 4 plus negative 6, and then we find the middle. So that's where my mistake was. So we get negative 5 is your line of symmetry. That makes more sense. Negative 5 is between negative 4 and negative 6. And to find the vertex, we're going to plug in that negative 5 into our factored form. So we get negative 5 plus 4, negative 5 plus 6, which is 3 times negative 1 times 1. All right, so there it is. F of negative 5 equals negative 3 if we multiply those together. Okay, so that point that we're looking at is negative 5, negative 3. Okay, so I'm going to plot a bunch of these points here. We're going to plot the x-intercepts, the y-intercept, the vertex, which is 0, negative 5, and then this, some of our other points. So we're going to sketch this. And again, my y-intercept's huge, 0, 72, so I'm just going to label it. All right, so here, negative 4, negative 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Oops, wrong way. 4. Okay, so here's negative 4. Here's negative 6. Those are our x-intercepts, so maybe I should do them in red. Oops. And then our equation for the axis of symmetry will be negative 5, 3. Okay, so this was wrong. I'm sorry here. Negative 5, 3 right here. So negative 5, negative 3, And let's do that in black. Actually, I'll do it in green. So here's -5, -3. And our y-intercept is 0.72. Okay, so that's way over here. So 0.72 is like somewhere here. I'm just going to label it 0.72. Okay, so if we were to sketch our function, it looks something like this. Let's just say it's up here. 0.72 is up here. All right, so there's a sketch of our graph using our x-intercepts, our y-intercept where we plug in a 0 and solve. And to find the line of symmetry, again, you find the middle, and you plug that point in to find the y value. Okay, so that's a review of what we did yesterday, sketching that high-quality graph there. Today, though, we're going to go back to that unit problem. In the fireworks problem, what do the x-intercepts represent? So if you remember that problem, you're on a platform and you launch some fireworks off, and they go off here. Here are my fireworks. And then the residue comes down, hits the ground. So the x-intercepts represent where it hits the ground, and the other x-intercept is negative because we started up on a platform. So one of the x-intercept represents where it hits the ground. And in the Angry Birds problem, same thing. We fire Angry Bird off, and then if you miss the pig here, here's our x-intercept at where it hits the ground. Okay, so those are x-intercepts where it hits the ground right here. Okay, and so again, let's practice finding the x-intercepts several different ways. So first thing that you look for when you factor is difference of squares, and oh, luckily we have difference of squares for number 1. This is when we take the square root of each one, so the square root of 9x squared is 3x. We put our plus, and 3x we put our minus. The square root of 16 is 4. And we want to know when does this equal 0? Okay, so I'm going to make an equation. Here's our first function, 3x plus 4 equals 0. 3x minus 4 equals 0, and you solve. So first step, we'll subtract 4 from each side. I put 5. So we get 3x equals -4, divide by 3. So x equals -4/3. So there's one of the zeros. And over here, it's very similar. We're going to add 4 to each side. 3x equals 4, divide by 3. So here we get x equals 4/3. So those are the zeros, -4/3 and 4/3. So to find the zeros, set it equal to 0 and solve. It's usually the opposite if x is by itself, but here we had that 3 there, so we had to use algebra to solve. Okay, so let's write in those zeros. There's not enough room to write here, so let's, whoops, and that didn't do anything for me. Okay, so I'll rewrite in the zeros here. So one of them was -4/3, and one of them was +4/3. So there's that. Okay, let's try the next one. Let's factor x squared minus 6x plus 9. Okay, and again, if you want to factor, there's several ways to do it. I'll use a box and circle. We got our x squared, our -6x, and our 9. So we want to know what multiplies to the first term and the last term. So multiplies to 9x squared, that adds to -6x. All right, so it multiplies to 9, that adds to -6 would be -3x and -3x. Let's get the outside of the box. We got x and x minus 3, x minus 3. So I should say k of x equals x minus 3, x minus 3. So the x-intercepts are what makes them 0. What makes these 0? 3. So this one has one x-intercept at 3. So it has one x-intercept. And so if we were to graph that graph, it might look like this. Something like that, where it just touches your graph once. Okay, let's take a look at this one. Try to factor -2x squared minus 2. All right, so can we pull out a greatest common factor? No. Let's try it in a box and see if that factors. So we have in our box -2x squared. We have a 0x and a -1. We want to know what multiplies to the first and the last box. So 2x squared, that adds to 0. Are there any numbers that multiply to 2 that add to 0? And there's not, so we can't factor, so not factorable. All right, let's graph this on our graphing calculator and see what we notice then. All right, so I'm just going to hit tab. I'm going to delete my previous graph and type in the new one. So we got 2x squared, and then it was -1. Oh, and notice it doesn't have any x-intercepts. It doesn't cross the x-axis. Not factorable. It doesn't cross the x-axis. Okay, so then it asks, what do you notice? It doesn't cross the x-axis. So it looks something like this. So it doesn't cross the x-axis. It means there's no x-intercepts. Okay, when is it possible for a quadratic equation to have one intercept? Well, when there's one factor, which is the same. So here's an example. This one had one x-intercept, so I had one factor, right? So x minus 3 when the factors are the same, one factor. When is it possible for a quadratic equation to have no x-intercepts? When you can't factor it. Can't factor it, then you can't find what equals 0, and there's no x-intercepts. Okay. So what we've learned today so far is if you can factor it, sometimes you have 2 x-intercepts, sometimes there's 1, and sometimes there's 0. So then the next point is to practice, again, writing in a quadratic equation given the x-intercepts and a point on a graph. Okay, so we're going to practice writing the equation today. Yesterday we went backwards, and from the equation we did the graph. Now from the graph can we write the equation? So the x-intercepts here are -1 and 5, and the y-intercept is -6. Okay, so how does that translate to an equation? First up, let's write the factored form. So the opposite of -1 is +1. The opposite of 5 is -5. Okay, but there might be a scale factor in front, and we call that scale factor A. So to find A, we plug in the y-intercept. So the y-intercept is -6, 0. So here's what we plug in. All right, we plug in everything that we know. This is our x value, this is our y. So 0 equals A. Oh, I'm sorry, this is the y-intercept, so let's switch this around. Okay, so this is the y-intercept is y equals. Okay, so the y-intercept is y equals -6. So the y-intercept is 0, -6. So let's plug this in for x and for y. -6 equals A times 0 plus 1, 0 plus 5. And let's solve that. So we get -6 equals A times 1 times 5. -6 equals 5A, and divide by 5. So here A equals -6/5. Okay, so then how do we rewrite our equation? Where we have this A right here, I'm going to erase that A and put in the A value, which is -6/5. But actually it's not negative, right, because we had a minus here, so I'm sorry. Let's redo this problem. Okay, so starting from here. Okay, so again, we plug in 0 plus 1, 0 minus 5. We're plugging in our x value here. And we get -6 equals 1 times -5. And then we had our A there too, so I need to put my A back in. Okay, so we're solving for A. And we get -6 equals -5 times A. And we'll divide each side by -5. So here A equals 6/5, which makes more sense because our graph is U-shaped up. It's not upside down. Okay, so our equation is y equals that 6/5, our A value, times our factor, which is x plus 1, x minus 5. Okay, let's try that again. Let's not make mistakes on this one. All right, we'll do number 9. Let me erase some of this here. Okay, so the x-intercepts are x equals, I'll put -3, and x equals 0.5. The y-intercept is y equals -3. To write the equation, we say y equals, we need an A value, and it's the opposite of our factor, so x plus 3, x minus 0.5. We plug in our point. The point that we plug in is the y-intercept, so this is 0, -3. We plug this in for x and y. So we want to know -3 when that equals A times 0 plus 3, 0 minus 0.5. and then we use algebra to solve. So we get negative 3 equals a, and then half of 3 is 1.5, and it's negative because of this minus right here. So 3 times negative 0.5 is negative 1.5, and then using algebra we divide by negative 1.5. And here our a value, negative divided by negative is a positive. 3 divided by 1.5 is 2. So here our a value is 2, and we rewrite this equation right here. If I can draw my lines here. Instead of the a, we put in our 2. So we're going to say, all right, y equals 2 times x plus 3 times x. I'm going to squeeze it in. I'll rewrite it. Okay, so again, y equals 2, x plus 3, x minus 0.5 is the equation. So we're going to solve this a value right here. We plug in the y-intercept, and we solve. Okay, let's try 2 more. And I apologize, there's not a lot of room here. Okay, so number 10, again, the x-intercepts are negative 4 and 4. The y-intercept is negative 16. Factored form of the equation, y equals a, x plus 4, x minus 4. Plug in your point, so we're plugging in 0, negative 16. So we get negative 16 equals a times, and again, these are 0, so I'm just going to do 4 times negative 4. We get negative 16 equals a times negative 16. And we're going to divide each side by negative 16. So here a is 1, so sometimes a is 1 here. If we rewrite the equation, we have y equals, if a is 1, I'll just leave it, x plus 4, x minus 4. Okay, and then the last one, oh look, we have one x-intercept here, but this is a double root. So when to make it curve back up, it actually is a double root here. So we have 2 x-intercepts since it curves. And the y-intercept is 9. Let's plug that in. So we're going to plug in the point 0, 9. Okay, so here's our equation. Y equals a, x plus 3. And I'm just going to put squared because there's 2 of them, or I could write it out. Oh, it's not x plus 3, I'm sorry, it's x minus 3. X minus 3, because it's the opposite of the factors. Let's plug in our point and solve. So we have 9 as our y value equals a times, plug in zeros for x, so negative 3 times negative 3. 9 equals a times 9. Okay, here another example of where a equals 1. So when you write our equation, y equals, we can put the 1 there, but we don't need to because it's 1. And it's x minus 3 squared because there's 2 of them. All right, so there's how we can take the graph and write the equation. All right, so there are several things here to practice that you'll look on your assignment and practice as well.